Welcome back. In this video, we're going to take care of setting the enemy's sprite sheet, as the enemy is going to have two different states, idle and run. Just like our character, we need to update those at the correct times. We also need to set the enemy's left-right float value, which determines whether or not the enemy should be facing the left or facing the right. Let's take a look at our code and see how we can do this. Now, in order to figure out how to do this for the enemy, we can see how it's done for the character. Here we are in the character's tick function, and what we're doing is creating a local vector called direction, and we're setting the value of direction based on which keys we're pressing. Now, if that direction vector does not have a length of 0, then we're normalizing it and scaling it by our speed and then adding it to our world position. This results in actually moving the character. Now we also check the direction's x value, see if it's less than 0, and if so, we set left-right to -1. Otherwise, we set it to +1. And we also handle setting the texture to the run sprite sheet, or if the direction does have a magnitude of 0, we set it to idle. So all of this functionality is already taken care of for us in the character class, but we need this functionality in the enemy class, and simply copying some code over to the enemy is not the best way to do it. We can use inheritance by moving some of this into the base character class. Now notice something. We have this vector value that represents the amount we wish to move the character by. In the enemy class, we also move the enemy by changing its world pause according to some vector value. Now, what if we used the same vector value in the enemy as we use for the character? Well, we could move some functionality into the base character tick function. Here's what we can do. Instead of having a to-target vector on the enemy and a direction vector on the character, we can simply have one vector member variable that the character and the enemy share. Let's go ahead and add that vector variable to the base character class here in the protected section. Let's go ahead and add this vector variable. So it's going to be a vector2, and rather than to-target or direction, let's call this velocity, because this vector contains information regarding the direction of movement as well as the distance we should move this particular frame. So let's go back to the character class, and here in the tick function, let's take a look at how we're handling movement. We normalize the direction vector, then scale it by speed. And after that, we add this vector to world pause. That's effectively applying the movement. So we can do all of this in the base character class, and then we can inherit this functionality, and it'll just be called in base character. So let's take this if-else statement here and copy it and delete it and move it over here into base character.cpp in the tick function. So here in the tick function, before we draw the character, we can update the movement. Now to use vector2 length, we're going to need raymath. So let's include that up here at the top. So we'll say include raymath.h. And now these vector operations are defined. Now we're not going to be using direction, instead we're using velocity. So we can replace direction with velocity here. So we're using it here in this line where we're updating the movement, and in this line where we're using it in our conditional for setting right-left. Now as soon as we update movement, we need to zero out the velocity. So just after the if-else statement, we can set velocity equal to an empty pair of braces, which will zero it out. Effectively, its x and y will now each be 0. So now that we're using this velocity vector, here in the character's tick function, instead of direction, we're going to use velocity. So we can change direction to velocity in each of these lines where we're handling the input. Now we're changing velocity here, and in the base character, we're using velocity to update the world pause, so the base character's tick function should be called after we update velocity, since the base character now uses velocity and then zeroes it out. So now that we're inheriting our movement functionality from base character, we can also use that in the enemy class in the tick function. Now here in the enemy's tick function, we're getting to target, which is the vector from the enemy to the character. We're normalizing it, scaling it by speed, and then adding it to the world pause vector. So aside from getting the direction that it should be pointing in, the normalizing, scaling, and adding to world pause is all going to be done in the base character tick function. So if we're going to use velocity instead of toTarget, we don't need these lines. So your challenge is to fix the enemy's tick function. In the enemy's tick function, instead of creating a local variable called toTarget, we're going to use velocity instead. So replace the use of toTarget with velocity. And also, you're going to delete all the code except for updating the velocity, that is, setting it equal to the vector from the enemy to the character, and then calling base character's tick, which handles normalizing it, scaling it, and adding it to the world pause vector. Now we're also setting the value of the screen pause variable, so you can leave that in. Pause the video and fix the enemy's tick function now. So here in the enemy's tick function, we no longer need this toTarget vector. Instead, we're going to use velocity. So we're setting velocity equal to the vector from the enemy to the character, but then our base character tick function is going to take care of normalizing that vector, scaling it by speed, and adding it to world pause, so we can remove these lines here. Now the base character will handle movement using our velocity vector and then zero it out, so it'll be reset for the next frame. Let's run this and see how it works. Okay, so we have our enemy chasing the character. Now before we wrap this up, I want you to notice how screen pause is simply a calculated value. There's really no need to store this as a variable. It's simply derived by subtracting the knight's world pause from the enemy's world pause. So to eliminate having an unnecessary vector value stored, we can simply have a getter function that will return the screen pause by deriving these. Now base character uses the screen position when drawing the character. So we can create a getter that calculates the screen position on the base character class. Now since the character defines the screen position differently than the enemy, it can have its own override of this function, and the enemy can have its own override. So let's go to base character, and instead of having a screen pause variable, let's create a function here in the public section that returns a vector2 called getScreenPause. Now since this is going to be overridden in character and enemy, it needs to be virtual. And we really don't need to define it here in base character. It only needs to be defined in character and enemy. So if we only want to declare it here, but we don't want to define it, we can make this a pure virtual function. Pure virtual functions are marked with equals 0. Once we have a pure virtual function on the base character class, the base character class is now said to be an abstract class, which means we cannot create an instance from it, we can only derive child classes from it. And that's exactly what we're using base character for. We're using it as a base class from which we can derive character and enemy. So since we don't even plan on creating an instance of the base character class, only classes that are derived from it, base character can be an abstract class. So now we have this pure virtual function, and we need to override it in character and enemy. Now in character.cpp, we're going to need to store winWidth and winHeight. So let's create two integer member variables on the character class. These can be private. We'll create an int called windowWidth with braced initialization, and an int called windowHeight, also with braced initialization. And in the character constructor, we're going to initialize these. So let's add a member initializer list and initialize windowWidth with winWidth and windowHeight with winHeight. So now the character is going to have the window width and window height stored as state instead of its screen pause. Now the character can override getScreenPause. So instead of having a simple getter here that returns this variable that no longer exists, we're going to override this function by marking it virtual and override, and then we're going to define it in the CPP file. So let's go to character.cpp, and just under the constructor, we'll define it here, and we're going to fully qualify the function with the class name. And what it's going to do is return the calculated value. It's going to be a vector2, and the value will be the results of this calculation that we did in the constructor. So copy this and paste it here in this vector2. Now instead of winWidth, we're going to use our member variable window width. And instead of win height, we're going to use window height. Now here's our semicolon. And now we can delete these lines from the constructor where we were assigning a value to screen pause. We're now deriving the screen pause with a function. Now in enemy.cpp, we derive screen pause a different way. We're subtracting the knight's world pause from the enemy's world pause, and that is the screen position. So let's override get screen pause in the enemy class as well. So it's going to be virtual, it'll return a vector2, and it's called get screen pause, and it's an override. Let's go ahead and define this in enemy.cpp. We'll stick it here under the tick function, and again, we'll fully qualify the function name with the class name. And this is simply going to return the value that's returned from the vector2 subtract. So we'll copy that from the tick function and paste it here. And now we don't need to set screen pause in tick. So we now have get screen pause, which calculates the screen position. But we're using this variable now that doesn't exist in both enemy and base character. So all we need to do now is call get screen pause instead. So we'll call get screen pause here, and let's copy this function call. And now let's go to base character, where we're using screen pause in multiple locations. Since we're using it here in the tick function as well as in get collision rec, we can just go to edit and replace. For find, we'll type screen pause, and for replace, we'll type get screen pause with the parentheses. Now it says this is instance 2 of 4, so let's go up to the first instance and click replace, and now we're using get screen pause instead of screen pause. Let's click replace again, and now it'll take us to the final 2 instances of screen pause. We'll go ahead and replace those as well. So in summary, we set the enemy's sprite sheet as well as its left-right value, and we migrated some code into the base character class so it's now inherited from the base character. We also eliminated unnecessary state by taking the screen pause variable out of the picture because it's a derived value, and we now have the function get screen pause which calculates this value from the world pause. And we saw that we needed a different implementation of this in the character versus the enemy, so we created get screen pause in the base character class and marked it as pure virtual with =0, which allowed us to avoid having to define it in the base character class. And this also now makes base character an abstract class, meaning it cannot be instantiated, we can't create an instance of it, only derived from. And that's exactly what we're using it for, a base class. We're only creating instances of classes derived from it, namely character and enemy. Great job. I'll see you in the next video.